So why Python? Python is a great language, and it's very easy to learn. If for a starter who does not know Python, you will take at maximum 2 to 3 days, to start writing programs in Python. It's that easy. If you have some kind of scripting language experience, be it batch scripting, shell scripting, it makes your life much more easier. Or for that matter, if you know any language, Python would be cakewalk. It'll be very easy to adapt and understand. The biggest strength of Python, and it's like I told you, right? It's the most preferred language by data scientists. It's because they have a bulk of library which is portable. It also supports GUI-based programming, and can be used to create applications on portable on Mac, Windows, Unix, and so on and so forth. And also point to be noted, it's open source, it's free. With libraries like PyDoop and SciPy, it's dream come true for big data. You do not have to write lines, hundreds and hundreds of lines of code like you normally do in Java. Let's say, for example, if you are writing 200 lines of code in Java, you will be writing at max 10 to 15 lines of code in Python. So it's that simple. Now, the growing interest in Python over time, right? Since July 2010, it has picked up, and lately there's a surge of people, wanting to know Python and learning Python. So it's just going to grow higher and higher. Now, I'll be taking you through a demo and web scraping using Python. So just to give you a brief as to what I plan to do, I plan to extract some basic financial data from Google.com Finance. If folks, some of you are, I'm sure some of you might be working in finance, so you would know as to what Google.com Finance website does, right? It gives you all the financial related information of companies, which I'm going to show it to you shortly. We shall use open source web scraping framework called Beautiful Soup. There are other packages as well which you can use, but for sake of simplicity, I'm using Beautiful Soup here. And scraping is used for a wide range of purpose, for data mining to monitoring and automated testing. So let me straight away get to the problem here. Now see, this is Google Finance, right? And let's say, for example, I want to see data related to SAP. All I do is, I search on SAP, and then I get all this information: range, 52 weeks, open, volume, market cap. So I'm not interested in this for now. For my example, what I would be interested is in this data. This is what I want. I want the net profit margin of SAP. I want the operating margin. I want EBITD margin, return on average asset, employees CDP score. These are the only data I'm interested for now. This is what I want to scrap the data for demo purpose. And I want to scrap data not just for IBM. I want to scrap data for Facebook as well, right? I just want to do a high-level comparison as to how this companies fare with each other, when you look at this financial data. So all this data, you can see all this data. So let's go to the code, and then you'll be surprised to see it's only so many lines of code, right? So like I told you, I'll be using Beautiful Soup, right? You see here I'm using Beautiful Soup, and I've listed a few companies like SAP, IBM, TCS, Oracle, Facebook, and Google, of whose data I want to pull. And just note here, right? See, I'm building an URL here. Although, if you are not from Python, you might not be able to understand it right now. I'm just giving you a gist. It'll take you maybe at max 2 to 3 days, to start working with Python. So don't worry about it. I'll just walk you through the logic as to how I did it, and how many lines of code is needed here. If you look at the entire code, half of them is about formatting, okay, and the actual code is hardly 5 to 6 lines. That's about it. And then I'm building a string. I just say Google.com Finance, and then I've given the name of the company here. If you go back to, let's say, here, see, this is how you can build your query, right? you see this finance, Facebook, let's say for example TCS, right? You get this data. So this is what I took into picture while creating my code. And now this is what I'm building here, the URL. I'm opening the URL using the beautiful soup, and then I'm reading the HTML. I'm reading the entire HTML. Let's say, for example, I want to read this. If you go and look at inspect element, you see all the code, and then you know that this is the net profit margin that I want, right? So I go here, and then I load it in my beautiful soup. I load the HTML in my beautiful soup, and then I make a note here, and then finally I go and check for class equal to column header. If I go and search here, column HEAD here, you see this. This is what I have done. I have checked for class equal to column header here, which is class equal to column header, and I pulled all this information, net profit margin, and so on and so forth here. So finally, I just find all the class which is column header, and then using some regular expression, I just finally print the data. I also find other information, class equal to LFT name, and so on and so forth, right? So let's run this, and then basically it's cleaning data. You see this RE regular expression. I've used regular expression. It's cleaning of data as to in which format I want the data to be there in my screen. So let's see. Give me 30 seconds. So say this data SAP IBM. Now let me stop my program from running. Now you see this. So for SAP, right, I get this information exactly as is. It's here in this. Okay, just give me a second. Now let me go back to SAP, and then let's validate whether that data is correct or not. Net profit margin 25.83, 25.83, 19.77, so on and so forth. Now having this data in one place, in one terminal, or maybe let's say in a file in Excel sheet, it's so easy for you to identify as to how the company stands. These are financial information. This is just one part of it, right? I can give me any website, and I can scrap anything that you want. So using Python and some of its package, it's extremely easy for you to pull all this data, study about companies, and make a decision of your own. So if you were to be a financial guy right now, you would find this information very useful. So that's about it. This is about beautiful soup and a little bit of Python. Now let's go back to the code, right? I mean, what's most important here? The most important things here are, you opening the page, you reading the page, you loading it with beautiful soup, and then you finding the class column header, and then you pulling all this information. So hardly there are 10 lines of code, which is important here. The rest are same. This is copy paste, and then if you look RE, wherever you see, it's regular expression saying that I just want to pull everything that is there from column header in my HTML. So that's about it, and this is about cleaning data. Pop means delete the data at the end. So that's about it. I mean, you do not have to worry a lot about this. This is all cleaning data. Like I told you, it's just 5 to 10 lines of code. That's about it. Now let's go back to our slide. Now this was web scraping using Python. Now let's go to collecting tweets using Python. Now you might say, right, all these days, social media analytics is a big thing. If you have been watching news lately, they do a lot of social media analytics. They do sentiment analysis. They do all kinds of analysis. I mean, if there is an election going on, they try to find a trend as to whether there is a positive sentiment or negative sentiment. If there is a movie, if there is you have Oscars going on, then they do sentiment analysis of movie. And just to give you an example, right? Last year, using big data, someone correctly predicted the first, the Oscar-winning actor, Oscar-winning movie, and Oscar-winning director. It was accurately predicted. I mean, it is to that extent we can predict the data. Now, you would ask me as to what technology did he use in order to do that. You can use any technology, but but if you are a data scientist, or if you intend to be a data scientist, you would definitely use Python. So let me give you a small example or demo of collecting tweets using Python. All of you might be in Twitter, right? You write a lot of things day in and day out. I myself tweet a lot. So how do you pull those data about something? Let's say about some individual, or let's say for example some shoes or some movies, anything, whichever you want to analyze. How do you do that? So this example demonstrates how to extract historical tweets for a particular brand like Nike or Apple. So this is one thing, right? The code that I have written is used to extract historical tweets. Now, if you want to pull the streaming data, you have other tools available, which are Hadoop ecosystem tools called Flume, right? Using Flume, you can pull those streaming data. But if you have to pull data from past, you have no way to do that in Facebook, in Twitter, Google Analytics, and so on and so forth. Take any social media name. So in those cases, we shall make use of REST API to call Twitter and extract tweets. And this data can be further used to perform, like I told you, right? It can be used to perform sentiment analysis. You can use natural language processing. That's one powerful algorithm, and whose package is again available in Python, right? Just think about any algorithm. Just think about anything that comes to your mind, when it comes to data processing, mining, or anything related to data, and it is available in Python. So it is, that's how much powerful it is. So let's go to my Twitter example. So this is a small code that I have written. You don't have to worry about this. If you go to dev.twitter.com, you get all this information. So no point copying my information. And I have just used one package, OAUTH2. There are many packages available in Twitter. I mean, people have already worked very hard creating these packages so that they can be reused. You do not have to write them. And then, these are again consumer token client, nothing to worry about it. This is how the package comes, and you have to provide this information. The important things here: you're logging into Twitter. You are, you're creating, you're putting this parameter. So right now, I want to analyze the data from Nike. I want to pull data related to Nike, all those data related to Nike. Now, you'd ask me, what is this 200? Twitter is very smart. They would not provide you data for free, right? And at max, for free, I mean, without paying any money, you can pull 3,200 tweets. And then on top of that, you cannot just pull 3,200 tweets in one shot. What you have to do is, you have to pull data in batches. So 200 is the batch size that has been defined. So if you have to pull data, you have to first pull 200 tweets, find a max ID. All these tweets have an identification number. It's like if you have 3,200 tweets, it will start from 1 to 3,200, and then you pull the first 3,200, and the 201 to again 400, and then 401 to 600, so on and so forth, right? So you build a parameter here using the user ID, which is Nike, and then the count, which is 200. You take this, you create your URL, which is the fixed URL of the Twitter source, and then the parameter here. And based on that, again here, just don't worry about all these things, okay? I created a program wherein you can pass dates, and then only for that particular date you can pull the tweets, and so on and so forth. I have been experimenting a lot with this, so don't worry about those things. So basically, if you are interested to pull Twitter data of yourselves, you can write your name here, and if there are many people with your name, it will pull all of their data as well. Or you can give your user ID, your login user ID, and it will pull your data, right? So here I have created a request URL. See, all you have to do is you have to pass that to a client.request. You pass the URL and you get a response. The response is JSON, okay? It's in JSON format. For folks who do not understand JSON format, it's something like XML. It's not exactly XML. XML has tags, but it has a format, but it's not completely structured. Okay, so So you'll get a lot of response there. You'll get the maximum ID, minimum ID, user information, the tweet count, retweet information, in a host of other information, hundreds of information. You'll get it here, and you'll also get header information. The only thing that you need here is you need the tweet, you need the text, right? You don't need any other thing. So here I'm trying to create the total pull count, so you do not have to worry about it. So this is the most important thing. You got a response, and then what I do here is I go to the response, and then I parse it. I parse the response here properly, and then finally what I do is I print the data. That's about it. You see this here. This is the most important thing here. You know, I parse the data from this date to this date. That is what I wanted to pull. You know, I pass this information and then I print it. So let me run this in code for you. And if you look at the lines of code that I have written, don't worry till here. It's almost you have to write it always. You know, just look at the number of lines of code. Half of them is commented, right? Hardly 15 lines of code. It takes a little time to run because it has to connect to Twitter, and then there is an authentication process, a handshake that is done, and then you start getting the data. That Twitter does authentication, and based on that, they send you data, right? So that's the reason why it takes some time. Okay, it's not like it takes minutes and minutes and hours. It hardly takes 30 seconds to 1 minute at max. But then you see, you have all the data of Nike. I mean, whoever has been writing about Nike, at maximum, I told you, right, it can be 3,200 tweets and not more than that, because beyond that, you know, you'll have to pay in order to buy this data, because this is actually sold. There are companies who survive on selling Twitter data. So it's that big a business. But for you, it's simple. You do not have to do anything. 5 to 10 lines of code and you are done. So that's why I say it's the most preferred language of data scientists. If you would want to grow into being a data scientist someday, this is one language you cannot ignore. You have to learn this, because if you start writing this code in Java or any other languages, then you cannot imagine as to how much time it will take and how many lines of code you'll end up writing. So again, going back, so you've seen this. Now you know how powerful how powerful Python is. But now I shall give you an example of word count using Hadoop streaming API. Okay, this example shows that simple word count application written in Python. We shall use Hadoop streaming API to run MapReduce code written in Python. Okay, I'm using Python to write a MapReduce code, and word count application can be used to index text, documents, files for a given search query. Let's do that now. Now, let me first show you as to what my inputs are. Okay, so this is my data. Okay, I took a very simple example in order to explain this to you, right? I did not want to make it complex. Now I have this. Let's say, for example, deer, beer, river, car, river. I just want to count the number of occurrence of each of these words. So the result that I want is. Okay, just give me a second. Success. I just want to show you the output before I actually show you the problem statement. Now, okay, fine. Let's run the program and then we'll see. Here, let me open one terminal. So this is how you look inside Hadoop, right? Generally, if you have worked on Linux shell scripting, you would do an ls, but I'm not doing ls here. I am doing Hadoop fs minus ls. So that's how you do. Now this is more of a Python class, so I'm not going to explain in detail that to you, which we can keep for later. Now you see this. This is the output that I want. Okay, let me copy this for your reference, and so all I wanted to do is I would take this input and then I would get this result. I would count each of the word that has been repeated. Deer is repeated DEER. This is DEER. So it has been repeated only once. DER is 1, DEER is 1. BEAR, beer has been repeated twice. So how is that done? How has that been done? So let me go to my install Hadoop folder, lscd. You see this mapper.py. I'll just show you what this is. Okay, I just take an input, the file as a standard input. I just split the words. I just strip whatever is there in there, new line characters and whatever is there. I just split the word, and then finally I pass word and one. Or for example, this is how the logic is. This is how the mapper works. Like I said, it's a key value pair. Every word would be split, and one will be assigned to it. And when you go, I'm sure many of you would not be able to understand this. Pardon me for that, guys, because I'll have to look into the time as well, right? And here all it does is it aggregates the data. Okay, you don't have to worry about this. See, I have given a comment for each of the code here. There is a comment for each of this code, and hence it's looking big. So how is it that you execute that? You execute it like this. You say Hadoop jar, and then you say this is all part of the syntax, so you do not have to worry. All you have to worry about is see Python, and then I'm giving the location of the Python mapper.py, Python reducer.py, and that's it. I run it like this. Okay, one second. Okay, it has started. Okay, it says the folder already exists, that's why it failed, and I give 6. Now it will run successfully. So there is no 6 file here. So the mapper and reducer has started, right? The map percentage is 0 and reduce percentage is 0 right now. So the whole idea of showing this to you was not to explain the map reduce per se. It was to show you that even using the streaming APIs and Python code, you can very well write your map reduce programs and then process huge amount of data. Now it says map is done, reduce is started. So here I wanted to show you something. See, it created this file. It created at 8:28, right? What's my time now? It is 8:29. So it just created this folder just now. It's still processing the data, and it says output is complete. So if I go here and then check in my SDFS, and whenever a Hadoop job is completed, it creates 3 files. One is a success file with 0 KB, a log file. So if there is any kind of failure, there will be something in log. Otherwise, there will be nothing in that, and a part 000 file. So that part 000 file, let's see what's there in that part 000 file. So this is exactly what I wanted, right? It's so easy. It's that simple. I mean, you might not find it so simple in the first time itself. Of course, I mean, it will take a couple of days learning for you to be acquainted with all these terminologies and then start doing things, start writing code. But I would guarantee you this, that with Python, this is 100 times more easier than Java or any other language. But if you're a Java expert, then good. I mean, you know, you would know both. So let me go back to, okay, let me minimize this. So I've given a demo on that. You know, this demo is done.